standard deviation is going to be talking about some deviation in some different data. So for example, or by definition, a deviation is the difference between a data value and the mean for the same data set. So if you have an average of 7, but you have different data values of 8, 9, 10, well, the deviation from 8 would be 1, the deviation from 9 would be 2, the deviation from 10 would be 3. But standard deviation is the measure of the dispersion or scatter of data values in relation to the mean. So basically, it's kind of talking about how spread out is this data. Few key things to make note of. And sorry, we'll talk about more standard deviation in our next section when we bring in a bell curve. But a low standard deviation indicates that most data values are very close to the mean. So low standard deviation means most of your values are very close to mean. In this one, I can quickly calculate it out as actually having a standard deviation of approximately 0.8. Now, that doesn't really make a lot of sense or a lot of rationale right now, but we'll talk about that in a second. So if a low standard deviation means that you're very close to the mean, a high standard deviation means that all your data values, or sorry, most of your data values are scattered much farther from the mean. There is a standard equation for it, which takes your, well, this is the variable in Greek that's meant for standard deviation. So it talks about standard deviation, but the actual letter is known as sigma. So the standard deviation, which is represented by the variable sigma, it takes the square root of all of this. Well, let's quickly look at what each of these parts are. This is also the Greek letter sigma. The big difference is this one is a lowercase and this one is an uppercase sigma. Now, when you put the uppercase sigma, it actually, so whenever the uppercase sigma, it means the sum. So if you take the sum of all of our x values, subtracting the mean squared, divided by the n, so in this case, we'll talk about the total amount of data values, and take the square root of that answer, you get your standard deviation. So we could actually quickly calculate all this out manually, but we'll leave that for a little bit later on. Just as a kind of fun note, since there's a lowercase sigma and uppercase sigma, well, there's lots of other lowercase and uppercase. There's actually about 24 or so in the Greek alphabet. For example, pi. Pi is a lowercase pi. The one that we use for 3.141522653589799223846264, so on and so forth. This is lowercase pi, whereas the uppercase pi actually looks very similar. And if the uppercase sigma means sum, the uppercase pi actually means product. So if instead here we have the product of all of this, well, we'd actually taking all of these values squared and taking the product of them, so multiplying them all together. That's kind of a fun bit of information. We really just need to know that this lowercase sigma means standard deviation. Now, what we are going to be doing is a standard deviation of a population. And I'll refer back to that into our first example. Of course, we also need to make sure that we know our mean, which is the average of a data set. So that's what that X bar is. So yes, we are going to go back into our first section where we have different bags. So we're going to check the accuracy of cartons that contain 227 gram and 454 gram bags of sunflower seeds. You're given the following data, and are finding which carton is more consistent for accuracy on the correct weight. What we're going to do is we're going to determine the standard deviation, because that talks about consistency. Standard deviation and consistency are very closely related. Now, in order to calculate the standard deviation using our calculator, it's these steps. So the first thing you need to do, make sure that all your data is cleared. Now, on the X2S, there's 3 different ways you can do it. You can press the on and clear at the same time. You can press second and then your negative, second and 0, which resets it. You just have to select the Y for yes. Or there is a reset button on the back. So here's how you do it. So that's the first kind of thing that you need to do. You just have to make sure that all your data is cleared. There is another way of doing it, especially when we are going into our data. And that's actually by pressing second. And we press our data, which acts, the first thing that you'll see is the one variable stat. And that's what you have to do. You're going to press enter. Now, if you press the over button instead, you have the 2 variable stat and go over one more, it actually does, it has the option of clearing your data as well. So that's another way. But let's go back to make sure that we press enter after it's selected on the 1 variable stat. Next thing we do is press data, because what we're going to do is we have to enter in some data. What you'll see next is you'll see an x1 equals, and what we're going to want to do is enter our data. Sorry, I should just have a comma there. So our data are these masses. So we'd have 228. And then we're going to press the down arrow. You'll see that there's a frequency number. And what we're going to have to do is we're going to have to enter the frequency. Actually, no, I don't need that comma. Now, frequency is basically how often you see it. Now, right now, I'm not looking too far into here, but I can see that there's only 228. Great. So I just have to press down again. And I have to repeat until I'm finished. So this 220, I then enter that one. 233. So I just have to basically go back to here, repeat here, go back to here, repeat, go back to here, repeat until I'm all done. So I have 233. Down, down, just because I know that there's only going to be the one, 277, and I continue on until my entire data set is filled in. We'll talk about things that have more frequency. For example, this 227. Well, there's another 227 here, which means after you've entered this one in, you could technically press it as a frequency of 2. So that's not too bad. And then you just have to press down. But you have to make sure that you don't enter that one in again. So when I press in my next data value, I press the 230. I can quickly look. No, there's no other 230s. So I'm going to leave my frequency as 1. But my next data value is not going to be 227. I'm going to have to put in 221. And I keep on going. Now I can see that there's 229s. So there's actually 3. Which means I can change my, when I put my 229 and press down, my frequency is going to be 3. And I can go 224. I see there's 2 of them. Great. I can leave 2. I can put 2 in. Then I press my down arrow. I have 223, or 231. When I press down, there's 4 of them. 1, 2, 3, 4. Now I'm keeping in mind what I've actually pressed in, because the next one I'm going to have to put in is the 226. I only see that there's 1 of them, so I'm going to leave the frequency as 1. When I press my 218, I see there's 1, 2, 3. Next number, 236. See that there's only the one of them, so I'm going to leave the frequency as 1. And after I've put all that in, see the last thing I'll make note of is that there's two 223s, and that's actually going to be on my X14. But I have to make sure I change my frequency to 2. So I repeat until I'm finished. My last step is to make sure I go down one more. So this XN is, you just have to make sure it's blank. So on mine, it's actually at X15. So I'm just going to make sure it's blank. It means that I've entered in all my data. I do not put anything into the last thing. And I press the button, stat var. Actually, I will for sure add that in, that it should be blank, and add a comma in there. You'll notice that on your screen, it comes out as a calc. Now, obviously, it looks like I've done something wrong because my N value right now is 24. So let's do some troubleshooting. We're going to have to go back into our data. So I'm going to have to press my data and see what have I put in. I put in my 228. And as I use my arrow down, I have one of them, 220, great. Frequency 1, 233, frequency 1, 277, yep, it's one of those. 227. I see there's 2 of them. So I should be at 6 right now. 230, 221, 229. I put in 3 of them, great. So I'm just going to make note of which ones I've actually put in. So it doesn't hurt to make sure that you've done things right, because I know that I should have 25. My next number is 224. I put in 2 of those, 231s. It looks like I obviously missed 235. So I'm going to have to make sure I put a 235 at the end. Just make sure that I put everything else in. 231, there should be 4 of them. Yep. 226, fantastic. Oh, just make sure note that. 218, put in 3. 236, there's 1 of them, and 223, there's 2 of them. So it's a great thing that I did make an error, so I know how to fix it. So the last thing I didn't put in was the 235. I still press my arrow down and make sure that my next one, so in this one, it's actually going to be 816. I'm going to make sure it's blank. So I press my stat var. It's going to show calc on the screen. And now I'm at 25 data values. That's what the N is. Tells you how many data values are there. So 25. Fantastic. That actually does help me. So X bar. So if I press my over arrow, the next thing that's shown on my screen is X bar, which is 228.76, which means I've now calculated the average of this just by using my calculator. Instead of having to add all of these up and then divide by 25, the calculator's done it. And at the same time, I can calculate a whole bunch of other things. I press over again, and I get this SX. So 11.30737223. Make that look like a 3. Then I go over again. I see the sigma x. So 11.07891. 691. Sigma x again. 5719, which basically means that is the sum of all of these numbers. And if I go over one more, it's 1 3 1 1 3 4 7, which means that is taking all of these numbers squared and adding them together. So if I took 229 squared and added to 231 squared, added to 236, and so on and so forth. So this is a lot of information. Some statisticians use different things for different reasons. I'm going to make note of these two things. First off, this Sx is a standard deviation, but it's only for a sample. Which means if this was only a part of a larger set. So if we just cut off these last two columns and just did the standard deviation on this, well, that would technically be our standard deviation of our sample part. So a part of the entire data set. What we do need is this sigma x. This is the one we want. This is not the one we want. We want the standard deviation, and it's actually the population, which means it is the standard deviation of all of this data. So the standard deviation, again, measures the dispersion in relation to the mean. So in relation to our average, which is 228.76, our data is kind of in generally spread out by approximately 11.0789. And we'll talk about what that dispersion looks like on the graph in our next section. But this is the number we want. So what we're going to do is we're going to enter in this data set using the same kind of steps. We're going to first clear off our data. Don't need it anymore because we have entered in everything that we need. We wrote down everything that we have. So I'm going to have to press second data, which acts as the one variable stats. I've already cleared my data, so I'm all good. And I just have to press enter and data. Data allows me to start entering in my stuff. So 458. Now let's see if I can do this one without any errors. So 250 or 458, say 1, 2. If I miss any, I just have to enter it in again. So 458. I press down my frequency. There's 2. So I've done these 2. 445. So 445, I can quickly look. Okay, there's 1, 2, 3. Initial look, I don't see any more. So 445. There's 3 of them. So 1, 2, 3. Next one, 457. So I see 1, 2, 3, and that looks it. Frequency of 3. Those ones have been entered in. 452. 1, 2. Any other 452s? Nope. Frequency of 2. So my next space is X5, because we've only entered in 4 different things. So the 5th data value that we're going to be entering in is 463. Are there any other 463s? Don't see them. It's 463. There's one of them. Fantastic. Press down again, 455. How many of them are there? 1, 2, 3. So frequency of 3. Make sure I've checked off that I've entered them in. Next one up, 451. 1, 2, 3. 451. Frequency of 3. Next one up, 460. I only see one of them, so I just keep on pressing down. 453, which is different than 463. There's only one of them. 456, I see that there's 4 of them. So my frequency is 4 on that one. And then 1, 2, 3, 4. Checked all the other ones. Last 2 ones that I have are 459, which is going to my X11, frequency of 1, and 450 going to X12. Press down. Make sure that I have the blank screen. So on X13 in this one. Make sure it's blank. Then I press my stat variable. Fantastic. I have 25 data values. X bar, by pressing over, it's 454.12. Now you'll note the mass of this set of data values should be averaging around 227. So it's a little bit off, about 1.76 off. Whereas this one is only 0.12 off, meaning more than likely when they're doing the measurements of these sunflower seeds, they are able to get a much more accurate value when they're able to sell in a higher bulk. I press over again. 4.63069469 Press over again. 4.53713566. Press over again. 11,353. And one more. 5 million. 156,139. So again, even though this is a standard deviation, it is not the standard deviation that we want. It's the standard deviation of a sample. We're taking the standard deviation of all of our values, which means that we need to take the standard deviation of this population. So the question is, which card is more consistent for have a correct weight? The 454 gram carton is much more consistent because this number is smaller than this. Our data values are not as dispersed from our mean in this set compared to this set. So, and at the same time, our average is much more accurate. So just like I said, it means that they are able to be much more accurate with a bigger bag than they are to a smaller bag. Now we'd have to have a larger set, say 1 kilogram, to see whether they would actually be more, even more accurate with a higher volume. But let's go into the next example. So when we know all of our data, we're able to use our graphing calculators or our standard calculators, basically our scientific, to determine standard deviation relatively quickly. Now, if we were using our graphing calculators, and I can show you how to do that, it's just more time consuming. With frequency, it becomes more difficult because you actually have to put in, so if we were using a different calculator, the large graphing calculators, we'd actually have to put 231 in 4 times. There's no option of having that frequency of 1. Again, that is why I severely encourage you to have bought the Texas Instruments 30X2S. 30X2S, sorry. Because it's something that can do a lot of things. Now, we will be using the graphing calculators to do some graphing, but that'll be a little bit later on. Now, to help us, especially if we do have frequencies, what we're going to do is we're going to use the midpoint of intervals. If we have intervals, like 3 to 5 hours, we're going to have to use the midpoint. So let's go into the example. So I'll do a little bit of rewording of this, so you may or may not see it. But that's going to be kind of irrelevant. So second example, we're doing a survey of the hours per week that grade 11 males play video games. The mean was 12.84 hours. Standard deviation was 2.16. Now, of course, I'm hoping that those hours are outside of your homework time. At the same time, you have an understanding that homework is assigned when you don't finish your work in school. You're given ample time, and if you're not working at a good speed, then yeah, you have homework. That's a fact of the matter. I know that I don't assign homework if you haven't, if I think that if you should have been able to get it done in class, you don't have homework. If your work slower, then yeah, that's how it happens. Okay, sorry. Mean of 12.84, standard deviation of 2.16. You do a similar survey with grade 11 females and get this information. We're going to compare the data. So it says that 7 females said that they had an average gaming time of 3 to 5 hours. 11 females had gaming time of 5 to 7. 16 had 7 to 9. 19 had 9 to 11. 12 had 11 to 13. And 5 had 13 to 15. So what we're going to do is we're going to find out what is the standard deviation. What is the standard deviation? Now the great thing is using our calculator, we can do the same thing. Let's go back and see what our steps are. Clear off our data. Press second, data. Make sure that we're having our one variable data. Press enter, press data. Now I can go over here. So because it's uncertain of whether some students had said 3 hours or 4.5 hours, we're going to have to use the midpoint of that data. So the midpoint of 3 to 5 is 4. So when we put it into our calculator, we are going to put 4 as our x1. The frequency is exactly what we have here. It's 7. So when we go down one more time, hours, midpoint, between 5 and 7 is 6. So we're going to have 6, frequency of 11. We're going to put 8, frequency of 16. 10, frequency of 19. 12, frequency of 12. And 14, frequency of 5. So I have to make sure I go down one more time, make sure I have completely clear. So my x7 is blank. Press my stat variable, and it calculates everything that I need. So for example, n is 70, and if we add all this up, see that's what we can do. Let's see, that's 18, that makes it 40. Add another 30. Right. Oh, I must have done something wrong. There should be 71. So let's go back. Fantastic. So data, I have 4 in 7 times, 6 in 11 times, 8, 16 times, 10, 19 times, 12, 12 times, 14, 5 times. Must be doing my math wrong. That's 18. Add 12. Makes it to 30. Oh, I was trying to add that again. That explains it. Okay, now we're all good. Because that's another 21. Sorry, 51. Yeah, 70. Okay, we're all good. So when I press my stat variable, I have 70 data values. My X bar, so my average, is 8.94. My sample standard deviation is 2.8. But my population standard deviation, which is what I want, is 2.78. Now I could keep on going over and get my sigma x and sigma x squared, but we can analyze our data just with what we have. We can see that the girls' average is much lower, but the standard deviation is much higher. So what that means is on average, girls play video games less. But boys play video games much more consistently close to their mean, because 2.16 is lower than 2.78. So meaning still, boys are playing more on average, and they're at a higher standard or a much more consistently around this number compared to girls being much less close to this one. And there we go. Now, in our last example, it's also possible to determine standard deviation manually for any set of data. Mathematicians will only really do this if they have a lot of free time, or if they're extremely bored, or if there's some actual practical application to it. Now, we're going to do it for fun because I am so much fun. And actually, some first-year university stat classes actually require you to do it at least once. So we're going to actually look at this equation. Sigma equals the square root of sigma of x minus x bar squared, all divided by n. So your x is each data value in your set. Your x bar is the mean of your data set. X minus x bar, so that part inside the brackets, is each value in your set subtracting the mean. This entire part here means you're going to square each subtraction, but the entire numerator means we're going to have to find the sum of each of those squares and then divide by how many total data values are. So we're going to do it for this 227 gram set. So we've already done the information. We should know what our answers are. Our standard deviation is going to come out as 11.0789. So let's do some work. First off, we need to find out what our average is. So if we take 228, add the 220, add everything all the way up to the 223 and the 223, divided by the fact that there's 25 data values, we should get 228.76. Now I'm kind of doing a little bit of cheat because we've already done it, 228.76. The rest of the values is what we're going to do in here. So this chart here is taking 228.76, and it would be each of those numbers. Wow, there's a lot of values. This column is where we take the x and subtracting the x bar. So I've just taken all of our data values from here, put them down here. So for example, 228 subtracting 228.76 should be 0.76. Negative. And when you do it in the chart, you'd have to then square it. So squaring it, it comes out as 0.5776. Similarly, if we take 230 subtracting 228.16 or 0.76, sorry, we get 1.24. A 1.24 squared is 1.5376. We're going to do that for the entire chart. Now I'm going to do that quickly without it being recorded. When the chart's done, it looks like this. I've taken every single one of these values, subtracted my average to give me this value, and then I've squared them to give me this. Yes, it is time consuming. At the same time, it does come out to be pretty rewarding. The next bit of our step is we have to take sigma of our x minus x bar squared, which means we need to add all of these numbers up together. So we have to have the 0.5776 add all the way up to the 33.1776. Again, I'll pause because you don't have to watch me or hear me type in every single one of these numbers. So when that gets plugged in, I get 3068.56. So the last bit of my work is I just have to take the square root, 3068.56, divided by the fact that there's 25 data values. So I just have to type all that in my calculator. There you go, 68.56. Divided by 25, taking the square root of it, and I get 11.078911691, which looks eerily similar to the exact same number that we got. So it does become a rewarding exercise to be able to do complex calculations manually. After that, you can have some fun.